Hello friends, welcome back to NPTEL online certification course on soil and water conservation engineering. I am Rajendra Singh, professor in agriculture and food in department of IIT Kharagpur. We are in week 6, this is lecture 26 and the topic today is gully control measures. Let us look at the course content for this particular week. We are starting this week today lecture 26, where we will be introducing gully control measures. In lecture 27, we will be covering gully control measures again, but the focus will be on permanent structures. Lecture 28 will be on design considerations for permanent gully control structures. And then in lectures 29 and 30, we will cover basics of open channel hydraulics in two parts, part 1 in lecture 29 and part 2 in lecture 30. So, let us start with the gully control measures, and the gully control measures, since prevention of the formation of a gully is easier and preferable than controlling an existing gully, one of the major steps in the gully control program is to plan the control of runoff from the drainage area. So, basically as the old saying goes, prevention is better than cure. So, obviously, if you can prevent the formation of the gully itself, that will always be better, economical, from environmental point of view also it will be better, and obviously preferable. And as we know the entire process of gully formation, you remember we have to go into the basics of the soil erosion mechanics. You remember that we started with the soil erosion and we said that it all starts with the raindrop splash erosion. So, whenever raindrop occurs, there will be splash and the loose soil particles will be spread on the surface. When the rain continues, after satisfying the infiltration requirement of the soil, after satisfying the infiltration capacity of the soil, flow starts on the surface, that is overland flow starts, and typically the flow is in the form of a thin sheet of layer, and that is why it is sometimes referred to as sheet flow. And once this flow starts taking place, whatever loose soil particles are there on the surface, they will be washed away, they will be taken along, or they will be carried along with the flowing water. And this kind of erosion is referred to as sheet erosion. And if the sheet flow is allowed to continue for long period of time, then on surface finger like structures are created, and these finger like structures are referred to as rills, and this erosion is referred to as rill erosion. But we also know that these rills can be easily taken care of by primary tillage equipments or through primary tillage operations. But we do not take care of these rills and allow the water to flow through these rills, slowly their dimension grows and gully formation occurs. So, basically in the nutshell, it is the flow which is responsible for right from the sheet erosion to rill erosion to the gully erosion. So, the formation, see the gully formation basically happens because of the flow or because of the runoff. So, that is why the statement here says that if we can control runoff, then obviously we can control the formation of the gully itself. Now, there are three possible ways of controlling runoff. One is retention of runoff in the gullied area. Second is diversion of runoff around gullied area, and third is conveyance of runoff through the gully. So, these are the three possible ways in which we can control runoff. So, let us see these possibilities one after the other. So, if we talk about the retention of runoff in the gullied area, then it is possible through good crop management and by adopting appropriate conservation practices. So, up till now, if you remember in several lectures where we are talking about soil conservation measures, we talked about the biological or vegetative measures. We also talked about the engineering measures, and some of these were contour farming, where we do all cultivation along the contour The strip cropping, where there are 3 types of strip cropping, remember, where strips are crops are grown in strips across the slope, or the engineering measures like bunding and terracing. So, either we can go for bunding a particular area or terracing a particular area, and we know that all these measures basically focus on conserving the water on the surface. So, I mean, if we if we go for contour farming or strip cropping, then whatever water is there, there are 2 things are there, that in between these contours, whatever area there, first thing we are cutting down the slope length, that we are not allowing flow to take for or flow through for a longer slope length, number 1. Number 2, we have provisions of storing the water in between 2 contours or in between strips, and because of that the infiltration opportunity time is more, that means more of water could infiltrate into the soil, and soil moisture reserve will go up initially, and finally groundwater recharge will also take place. Same is the concept in bunding, contour bunding especially, and the terracing, that is bench terracing or even the level type of terracing, which are focused more on moisture conservation. So, we know that where contour bunds are used, runoff is greatly reduced, because we know that we have discussed in great detail that when we build contours, then obviously what we see that this particular area which acts as a catchment area in between these 2 contours. So, whatever rainfall occurs there, that we would focus on retaining that over that particular area. We do not allow water to flow away. So, that is why runoff is controlled or runoff is completely conserved within the contour area. So, on cultivated areas, small and medium sized gullies can also be reclaimed by placing a series of earth fields across the gully. So, already we have seen contour farming, strip cropping, bunding and terracing. These are effective measures for retaining runoff within the gullied area or the catchment which is affected by gully formation. But even in the cultivated areas where there are small or medium sized gullies are there, they can be reclaimed. If we cannot go for any of these measures, then at least by placing a series of earth fields across the gully. So, these earth fields, which if they are placed across the gully, they will nothing but act like contour bunds or a dam in the gully itself, and that means whatever water is there in between 2 of these earth fields, that will be conserved. Also, these earth fields will cut the slope length. Also, they will not allow, or rather they will regulate the flow of water. So, because of that also it will be possible to retain most of the runoff within the gullied area, and over the period the grasses or the vegetation will grow and gully could be reclaimed in this particular fashion. So, this is how retention of runoff in the gullied area is possible. But here many times we are referring to small, medium gullies. So, it is worthwhile to have a relook at the gully classification as per size, because throughout the lecture or following lectures we will be again referring to this small, medium and large size several times. So, it is worthwhile to have a relook at the gully classification as per size. So, a small gully, earlier we classified that a small gully is called small when the gully depth is less than 1 meters and the contributing drainage area is less than 2 hectares. It is referred to as medium when the depth varies over 1 to 5 meters and drainage area varies over 2 to 20 hectares, and a gully is referred as large when the depth is greater than 5 meters and drainage area is greater than 20 hectares. So, just now we said small and medium gullies can be reclaimed by putting earth fields. So, that means we are talking about the gully within these classes, that is where the depth was limited to 5 meters and the drainage area was limited to 20 hectares. So, this is the table. I mean, whenever we say small or medium or large, will be referring to these numbers or these parameters. Then next is diversion of gully runoff around gullied area. So, complete elimination of runoff from the gullied area is of course the most effective control. So, just now we saw that if we can retain everything within the gully area, then there is nothing like that. And but if it is not possible, then the other alternative is to divert the runoff around the gullied area, and for that terraces and diversion ditches can be used for diverting runoff from its natural outlet. And terraces are very effective in control of small gullies on cultivated fields or even medium size shallow gullies. So, basically what we are saying is that if because gully typically if this is the gully, so gully typically will, if flow is allowed along the gully, it will go to its natural outlet. But what we are saying here, that we will divert the flow, we will not allow the flow to pass through this gully, but we will divert the flow. So, we will construct terraces or diversion ditches, so that the flow can be taken to a different outlet, and so flow will not pass through the gullied area, that is the function here. So, if the slope above a gully is too steep for terracing, or if the drainage area is pasture or woodland, then diversion ditches may be used to keep the runoff out of gully. So, if terracing is possible, then obviously we will go for terracing, but if the slope conditions or the cultivation conditions or land use is such that it is not worthwhile to go for terraces, then we can straight away go for diversion ditches. And already we have discussed that function of these terraces or diversion would be to divert runoff from the natural outlet of a particular watershed or catchment, which is a gullied area that we are talking about. And third option is conveyance of runoff through the gully itself. So, if it is not possible to either retain or divert runoff, we saw that for retaining the runoff, we should have strip cropping, contour farming or engineering measures like contouring or terracing. But if that is not possible, then we saw the divertings, that is, we can use terraces or diversion to take the flow away to another outlet. But if these possibilities are not there, then obviously we have no option but to allow the runoff to be conveyed to the gully itself. So, gully has to be used for conveying the excess flow, and for that, I mean, that can be possible if vegetation is established in the gully. So, obviously, since we do not have any option but to allow the flow to pass through gully. So, then we must take precautions that the flow is at a non-erosive velocity, that it does not cause any erosion of the gully bed or the gully sides. So, that the size of gully may not extend, and also no erosion takes place. So, non-erosive flow velocity, and for that it is essential that vegetation is established in the gully. So, if vegetation bed and sides are completely covered, so that means they are a gully is converted mostly into a vegetative waterway or into a vegetated waterway, then obviously, if the flow takes place, then that will not be addressed. Only thing we have to see that flow is allowed to take place at a non-erosive velocity. Then other possibility could be that soil conservation structures are built at critical points to give primary control. So, along vegetation we can also go for soil conservation structures like dams, which are like we discussed just earlier we discussed earth fields also. So, earth fields or dams, so that if they are constructed, so they will cut down the flow length, number one. Then obviously, because they will have certain certain sill height over which the flow is allowed to take place. So, obviously, there will be some temporary storage within the gullied area or the gully itself, and that will allow the water to infiltrate. That means, the total flow can be reduced to certain extent. So, that means, these are the three possibilities: either we retain the entire runoff in the gullied area if possible, if not, then we convey the water or divert the water to another outlet by using terraces or diversion ditches. And If both these are not possible and we have to definitely convey the water through the gully itself, then we have to see that first the gully is completely covered with vegetation, or it basically becomes, it behaves like a vegetative waterway. And if flow is even more, then we can even take the help of some kind of soil conservation structures that can be built across the gully to further control the flow or to cut down the slope length and the total flow also. So, these are the possibilities of controlling runoff. So, either of those we can adopt. Now, gully control measures if we see, then broadly they can be classified into two categories: biological or vegetative measures and engineering measures. They are the two different sides. And if you look at the biological or vegetative measures, then there are several possibilities like sod flumes, anti-erosion cropping or crops, low sodded earth fills, changing gully into grassed waterway, sod strip checks, tree shrubs. So, there are many possibilities utilizing which the gully can be controlled, and all these belong to biological or vegetative measures, because as you can see that some kind of vegetation is involved in all of these. Then on the other side we have engineering measures. If the flow is much larger or significant, then obviously we have to go for engineering measures, and engineering measures can further be classified into two categories: the temporary gully control structures and permanent gully control structures. So, we have biological or vegetative measures, we have engineering measures, and engineering measures can be further classified as temporary gully control structures or permanent gully control structures. And if we talk about the measures to control gully, then we have, of course, we have just now seen biological or vegetative measures, where anti-erosion crops are grown that not only stabilize the gully, but they can also supplement the income. So, for stabilizing the gully, we grow some kind of anti-erosion crops, and of course, because some these crops are grown, so supplementary income will also be there, and they may be supplemented by gully control structures, as we have seen by earth fill and all. Then on the engineering measures, we have temporary gully control structures, which are effective for low runoff and have a life of 3 to 8 years, and other categories permanent gully control structures, and we will see each one of them in great detail in this lecture or in following lectures. So, today we look into vegetative measures, various vegetative measures. One of them is converting gully into a grassed waterway. Just now we saw that if you have to convey the flow of water through the gully, then one way is to convert gully into a grassed waterway, and small and medium sized gullies can be converted into grass waterways, and that is why we are seeing that we always refer to these sizes small and medium. So, that means if you refer the value, that means the depth is limited to 5 meters and the drainage area is limited to 20 hectares. That is when we say small and medium sized gullies. So, they can be converted into grass waterway. In practice, gully is shaped and suitable species of grasses are grown. So, some kind of shape is given to the gully, may be parabolic, as we discussed the various grass waterways. They can be triangular, trapezoidal or parabolic. Parabolic is more practical. So, some kind of shape has to be provided and a suitable species of grass has to be grown, and already we have seen that there can be various types of grasses we have seen and discussed during the vegetative waterway, when we are just talking about the vegetative waterway. And channel cross sections should be broad and flat to keep water spread uniformly over a wide area, and that is primarily because every time we have to talk about non-erosive, either non-erosive velocity, or we also used another term, permissible velocity. So, either of these we have to keep the velocity limited to these either non-erosive or permissible, so that the flowing water cannot cause any erosion. So, that is why the cross section has to be flat enough, so that velocity is limited to within the permissible limits or within the non-erosive limits. So, this we have to take care of. Next measure could be sod flumes. Sod is nothing but turf, basically, that is soil with grass, that is sod, that is other common term used is turf. So, this is used to control overfall in gullies with less than 3 meter head and 10 hectare area. So, kind of medium gully it can be controlled. So, total over the length, the total fall is less than limited to 3 meters and the area, drainage area is 10 hectares. And because it is a short flume, so as you can see basically there will be a flume kind of structure will be provided. That means a sloping the sorts will be placed in such a way that it acts like a flume through over which the water flows through. And the slope that is to be provided, that is the slope we are talking about, that depends on soil type, size of the watershed, height of overfall and type of sod used. Basically, when we say size of the watershed, basically the flow magnitude, that is that the structure has to handle. Soil type talks about the stability of slope, that is we know that the slope is always decided for even for bunds etc., based on the soil type. The height of air overfall will also determine the how much energy is to be absorbed, and type of sod used, that is what kind of turf we are using. All these will govern what is the type of slope. And to maintain a non-erosive velocity, flume should be wide enough. Just now we discussed for gully also that we have to maintain a non-erosive velocity of flow over the net, and maximum depth of flow over the flume should not exceed 30 centimeters. So, this is another limitation, that the flow depth here on the surface, this is the flow depth we are talking about, that is limited to 30 centimeters. So, but these are practically used in field conditions and vegetative measures. Then the other measure could be where again sorts are used, and this time the measure is called sod strip checks. So, basically these are best adopted in small gullies that have a small to medium sized watersheds. So, small gullies, small to medium sized watersheds. Then here the name itself suggests we use sod strips actually as check. So, strips are laid across gully channel having a minimum width of 30 centimeters and extending at least 15 centimeter on gully sides. So, basically as you can see here that the width of these strips which are provided. So, you can see that a series of strips are provided, sodded strips, that means the turf is basically put here to form these strips, and usually these strips, width of these strips is 30 centimeters, and the strip spacing usually varies from 1.5 to 2 meters. So, strip to strip distance is 1.5 to 2 meters, and is already mentioned that not only the bed, the channel blade or gully bed, but also it is extended to the sides. So, that the sides are also protected. So, there is no erosion or soil sediment coming from the sides into the channel bed. So, this is what we have to be careful. Then we have third category is sod checks. So, they can be used as substitute temporary gully control structures in small and medium sized gullies. So, they behave more like a temporary gully control structure. So, here you can see that sods are put and to form a kind of a dam basically. So, this is nothing but we can also call it a sod dam. A kind of dam is put here across the gully, and typical dimensions of these are maximum height is 45 centimeters, upstream side slope is 3:1 and downstream side slope is 4:1. So, we see that the approach as well on the downside we have a flatter slope. So, that suddenly water does not approach these structures, and also while flowing out it does not fall directly, but passes through a flat slope. So, that the velocity is under control and not too much of kinetic energy is generated. So, that is why these typical dimensions are used in the case of the sod checks. Then we have temporary gully control structures. The next, and the temporary gully control structures are made from locally available materials and a life of 3 to 8 years. This is also important thing is that they are made of locally available materials and for a life of 3 to 8 years. And various temporary gully control structures could be woven wire check dam, brush dam, loose rock dam, plank or slab dam, and basic purpose they serve as retain more water as well as soil for proper plant growth, that is basically soil and water conservation, and prevent channel erosion until satisfactory vegetation is established. So, basically gully reclamation, so that vegetation grows sufficiently, so that no further erosion or no extension inside of the gully could take place. So, design criteria for temporary checks are: the overall height of these temporary structures should be limited to 75 centimeters. This is important thing. Then spillway capacity of the check dam is generally designed to handle peak runoff that may be expected over 5 to 10 years. So, 3 to 8 years of life. So, that is why the frequency at which the peak runoff, either rate or the volume, has to be calculated as 5 to 10 years. And next condition is that this basically deals with the spacing between the temporary checks. So, check dams theoretically should be spaced in such a way that the crest elevation of one will be same as the bottom elevation of the adjacent dam upstream. So, this is the top, this is the bottom. So, they should be aligned in such a way that this bottom matches with the top here or the crest here, and obviously that will the elevation will depend on or the distance will depend on the land slope. Basically, the land slope will govern the spacing basically. And of course, another one important part is that most of the check dams an apron must be provided. So, on downstream side an apron has to be provided, so that to catch the water falling over the top and to conduct it safely without scouring, so that no scouring takes place on the downstream side. So, let us start with woven wire check dams used in gullies of moderate slope and small drainage area. Dam is commonly built in half moon shape with open. So, this is basically half moon shape, and it shows that flow is coming from this side, and offset equal to 1/6 of the width of the gully at the dam site is optimum. So, this offset, when we say this is offset basically. So, what kind of a dia is used, that is governed by this offset. So, this offset is 1/6. Then continuing with this, a row of posts is set along the curve of the proposed dam at about 1.2 meter interval and 60 to 90 centimeter deep. So, this is the interval is 1.2 meters, and these are going up to 60 to 90 centimeters. Heavy gauge woven wire is placed against the post with the lower part set at 15-20 deep, so that 25 to 30 centimeter projects above the ground surface along the spillway interval. So, that means the woven wire goes even below the surface, soil surface. This is the soil surface, this is the woven wire, you can see. So, it is placed even below the surface. A short fill is used on the upstream side to regulate the flow over the crest. So, some kind of fill is used, so that water gets stand. So, suddenly a large flow does not hit the structure, and rock, brush or shod may be placed for the length of 1.2 meters to form the apron. So, on the downstream side we have apron, and on the upstream side we have a short fill. So, these protections are also provided. Then we have brush dams. They are best suited for gullies with small drainage area. For a distance of 3 to 4.5 meters along the site of the structure, sides and bottom of the gully are covered with thin layer of straw or similar fine mulch. So, wherever we decide that we will put the structure, so over around 3 to 4.5 meters, we put the straw or fine mulch. Brushes are then packed close together over this mulch. So, then brushes are put together, and several rows of stakes are driven crosswise in gully with rows 60 centimeter apart and stakes 30 to 60 meter apart in the rows. So, several rows you can see row 1, row 2, row 3 we will put several stakes, and then finally, heavy galvanized wire is used to fasten the stakes in a row as well as firmly compress the bushes in place. So, that I mean there are several rows. So, they block the flow of water, they conserve the energy of the flow and also control the flow, so that erosive velocity could be controlled. Next is a loose rock dam. So, as the name itself suggests, in this case we use loose rocks, and these are also suitable for small to medium sized drainage area. A trench is first made across the gully to a depth of about 30 centimeter to form the base. So, a depth is used 30 centimeter to base is formed. Flat stones are the best choice, as they can be laid in such a way that entire structure is keyed together. So, if stones are flat, then one over the other they can be laid, and the center of dam is kept lower than the sides of to form spillway. So, this is the center. So, center is always kept. So, some kind of depression is there. So, that acts as a weir opening, and to serve as an apron, several large flat rocks may be countersunk below the spillway, extending about 1 meter downstream from the base of the dam. So, on the downstream side we will provide apron by countersinking large flat rocks for about 1 meter length. Then we have plank or slab dam, which is suitable for areas with plentiful of timber, suitable for gullies with large drainage areas, and these planks are placed across the gully to form the dam. So, as you can see here, these planks are placed to form the dam, and suitable opening for the spillway notch is made over the head wall. So, some kind of opening will be provided here. So, some kind of I mean when these are placed, they are placed something like this. So, that a suitable opening is there. And on the downstream side, on the upstream face, a well tempered earth fill is made, again like so that flow comes smoothly, and on the downstream side apron is made for loose. So, almost in all cases we have to see that flow approaches, there is some kind of approach, and there is a apron, that is a must. And lastly, we have log dam, which is the stabilized gully heads. So, basically locks are used here. They are used for gully stabilization which are less than 100 meter in length, and catchment area is less than 2 hectares, and the maximum height of dam is 1.5 meters from the ground surface. So, there you can see that it is the maximum 1.5 meters from the ground surface. This is the natural ground, and the spillway is rectangular in shape. Typical rectangular spillway is provided, that is in most of the cases either rectangular or semicircular, and the length and depth of the spillway is 1 to 2 meters and 0.5 to 6 meters respectively. So, this is 0.5 to 6 meters, and this spillway length is here, it is 1 to 2 meters. So, these are the typical dimensions which are recommended. So, we have seen that we have vegetative or biological measures on one hand, then we have also temporary structures which are made by locally available materials. So, if logs or slabs are available, we will go for that. If only sots are there, then we will use them. If nothing else is there, we can convert the gully into vegetative waterway. So, I mean depending upon the availability and depending upon the size of the gully as well as the drainage area, will either adopt biological measures or temporary gully control structures. And so that the whole idea is that the flow is controlled, and so that no erosion could take place, no further erosion could take place in the gullied area. So, with this background, we will close today, and then we will see about the permanent gully control structures in the next lecture. Thank you very much.